faithfully delivering value and interpreting great books worldwide. Hello, this is Sally Book Talks. Today I'm interpreting the book The Hidden Reality for you. The subtitle is What are Parallel Universes? So, what exactly are parallel universes? Simply put, our universe isn't the only one out there. There are many other universes out there. This isn't science fiction imagination, it's a conclusion scientists have reasoned out. However, parallel universes are still just thought experiments by scientists. We can't precisely define them yet. The book, The Hidden Reality, we're discussing today also can't precisely define what parallel universes are, but it offers up to 9 possible parallel universe models. Some far away, some close at hand, some transcending dimensions, some involving cycles of rebirth. Liu Qixin, author of The Three-Body Problem, said in the foreword that even sci fiction novels dare not describe such a mind-blowing, crazy imagination that leaves one dizzy. The New York Times Book Review commented that if aliens invaded Earth tomorrow and wanted humanity's highest wisdom, the worst thing would be letting them find this book. The author of this book, Brian Greene, is a renowned American physicist, a leading figure in string theory, and a popular science writer. He's charismatic and has appeared in multiple science documentaries and films. After publication, The Hidden Reality topped Amazon's bestseller list in its category for months. Now, I'll summarize the 9 types of parallel universes from the book into 3 groups for you. So, the first group is parallel universes based on mature theories derived from concepts like inflation theory and quantum mechanics. The second group involves parallel universes related to string theory. String theory is a new, unproven framework from which various parallel universes can also emerge. The third group is parallel universes built on philosophical speculation, transcending science to explore the universe from a deeper philosophical angle. First, let's start with the simplest first group and see what parallel universes arise from mature theoretical frameworks. Let's examine the first and simplest parallel universe model, which can be derived using mathematical permutations and combinations. First, let's ponder a fundamental question. Is the universe finite or infinite? Scientists still don't have a clear answer because both scenarios have supporting evidence in our discussion. And based on the infinite universe theory, although cosmic space is infinite, our observable universe is finite, only 41 billion light-years across. This farthest observable boundary is called the cosmic horizon. We cannot observe anything beyond the horizon, and evolutionary processes inside and outside are completely independent. If cosmic space is compared to a huge infinite quilt, each cosmic horizon is like a patch of floral fabric sewn onto it. Each patch represents an independent universe existing beyond each other's horizons. This is the first parallel universe model, called the patchwork quilt parallel universe. In this model, each universe has a finite number of particles. Each floral pattern represents a specific arrangement of particles. There are 10 to the 2222 possible particle arrangements in our universe, meaning only that many floral patterns exist. If the cosmic quilt is infinite, repeating patterns must emerge, implying another version of you exists. Our bodies and minds are merely manifestations of particle arrangements. Determine the arrangement, and you determine everything. So in an infinite universe, countless copies of you exist, replicated infinitely in the patchwork quilt cosmos. Every opportunity you missed, every choice you abandoned, plays out in another universe. Okay, that's it. You've only experienced the most ordinary parallel universe, requiring just infinite space or time. Equally capable of producing parallel universes is the second model, the inflationary parallel universe. This concept was proposed to refine the Big Bang theory. So it suggests that within less than a second after creation, cosmic space underwent exponential inflation. Scientists proposed a field called the inflation field, analogous to electromagnetic fields. Where the field exists, there's energy. The inflation field contains energy that expands space. Higher energy means faster expansion, and space expanded by high-energy inflation fields creates more high-energy fields, spreading inflation like a virus that never stops. And so, the universe presents a new picture. Imagine space as a super huge piece of cheese. Here, the solid parts represent regions of rapid inflation, while the holes represent regions of slow inflation. Just like our current universe, where hyperfast inflation has stopped, and holes randomly appear in the gaps between solids. Meanwhile, the solid parts keep inflating forever, making this cheese grow larger and larger, leading to more holes randomly forming within. At the same time, because the solid parts inflate so rapidly, the separation speed between holes exceeds the speed of light. No matter how much time passes or how advanced technology becomes, there's no way to cross this boundary, not even to send signals to each other. Therefore, each hole becomes an independent universe, called a bubble universe. Bubble universe might sound small, but don't let your imagination be limited. Inflation theory, what inflates is the vast expanse of cosmic space, embedded within an even broader space. Within this giant cheese, scientists have calculated a counterintuitive and startling conclusion. If you look down at the entire cheese, each bubble universe has finite space. But if you enter inside a bubble, each bubble universe appears infinite, like Hamlet's famous line, "I could be bounded in a nutshell and count myself a king of infinite space." What does an infinitely large bubble universe imply? It implies that within it, patchwork quilt parallel universes can emerge. That is, in a vast inflationary parallel universe system, every part is a patchwork quilt parallel universe. We're actually living in parallel universes within parallel universes. Next, the third type of parallel universe is easier to grasp, the quantum parallel universe. It's based on quantum mechanics. Quantum mechanics has a concept called superposition, meaning a quantum can exist in countless states simultaneously, but when observed, it appears in one definite state. You might have heard of Schrodinger's cat. A box contains an atom-controlled poison device and a kitten. If the atom decays, it releases poison. But since the atom is in a superposition of decayed and not decayed, the kitten is both dead and alive. To resolve this, people introduced the quantum parallel universe explanation. He believes that when we observe, the entire universe splits into parallel universes, each corresponding to a different outcome. In this universe, the cat died. But in another universe, the cat is perfectly fine. So every possible outcome actually happens in its own separate universe. That's the quantum parallel universe. So then, if the universe splits into multiple versions, why do we see superposition effects? We can explain it this way. When few particles cause the split, parallel universes maintain faint connections. But once more particles get involved, that connection gets severed. In physics terms, this is called decoherence, meaning they stop interfering with each other. That's why quantum objects lose superposition when we observe them. Because observation instruments involve many particles, their involvement severs the connection between parallel universes. So far, we've covered 3 parallel universe models based on established physics. Next, we'll explore a group of parallel universes tied to a new, unproven theory. That theory is string theory. First, what exactly is string theory? It proposes that the universe's basic units aren't particles but tiny strings, like violin strings, and particles are just vibrations of these strings. All strings are identical, but different vibrations create different particles. Thus, everything in existence unifies under this concept of strings. But why should string theory only have strings? Couldn't there be other shapes? Actually, yes! Scientists first discovered there aren't 1, but 5 different versions of string theory. Amazingly, these 5 seemingly distinct versions can transform into each other. So they unified into a framework called the theory, which translates to brain theory. From this theory emerged new shapes, like 2D flying carpets, brains extending to 3D, 4D, up to 10D brains. These brains vibrate and oscillate just like strings. In other words, strings are just one-dimensional brains. In brain theory, the universe has 10 spatial dimensions plus 1 time dimension. 11 dimensions total. And within this brain theory, we find a fourth parallel universe model, the brain multiverse. Imagine our universe as a massive three-dimensional brain, like a slice of bread, the very foundation of our space. We live within this three-dimensional brain like fish in water, and such brains aren't unique.
The theory has 11 space-time dimensions. Higher dimensional space can accommodate multiple three-dimensional brains.
Meaning, alongside our bread slice universe float countless others, some whole wheat, some buttery, scattered haphazardly around us. But why can't we see these bread slices? Can we fly outside the brain? No, but why? This brings us to string shapes. Open strings and closed strings. Open strings are like ordinary threads, one end tethered to the brain, forever trapped. You, me, all ordinary matter. Open strings.
Though you jump and bounce, your open string endpoints imprison you on the brain. Escape is impossible.
But one thing's different. Gravity. Its closed strings form loops with no endpoints, slipping through brains into higher dimensions. Thus, gravity freely traverses brain worlds in higher dimensions, our only tool to probe beyond. If you've seen Interstellar, this scene will resonate. A father in five-dimensional space manipulates a watch's hands to send messages to his daughter on Earth. The force enabling this cross-dimensional communication. Gravity. Yet in reality, gravity's the weakest force. We've detected no extra dimensions. Next, from brain multiverses emerges the fifth model, cyclic parallel universes. Picture countless brains floating freely in higher dimensional space. What happens when two moving brains collide? Like colliding rafts on a river, they unleash searing particles and radiation, obliterating all structures in a cataclysmic Big Bang. Someone suggested a fitting name for this process, the Big Rip. After collision, they don't merge but rebound, moving apart, cooling, and nurturing new universes. When maximum separation is reached, they approach again, leading to new collisions. Then each brain returns to blazing fire, destroyed again, starting a new collision cycle. This cosmic theory's essence is a world cycling through explosions and rebirths, forming the cyclic parallel universe. A full collision cycle, birth to death, takes about 1 trillion years in this cosmic tango. Our universe is merely the latest. Countless existed before. Some universes may have hosted intelligent life and cultures now reduced to ashes. By this theory, everything in our universe will eventually vanish too. The most controversial aspect is how cyclic universes sidestep the origin question. If you ask when the cosmic cycle began, previously, the answer was simple. No beginning existed. Because the cycle is eternally recurring, string theory's most baffling derivation is the sixth parallel universe, the landscape multiverse. This model depends on an effect called quantum tunneling. Tunnels tunnel, traverses traverse. What is quantum tunneling? An electron hitting 500-meter steel? Classical physics says impossible, but quantum mechanics allows a tiny probability. Given enough time, quantum particles can tunnel through any barrier. Now scale this quantum tunneling effect to the entire universe. Recall the cosmic cheese analogy from earlier inflationary universe discussions? Space divided into rapidly inflating cheese solids, high-energy inflation fields, and inflation-halted holes, low-energy regions. Relatively simple division. Visualize high-energy areas as mountain peaks, low-energy as valleys. String theory's reality is far more complex. The energy distribution isn't just peaks and valleys. It's like a rugged, undulating mountain landscape. With peaks, valleys, plains, hills, plateaus, and basins, energy typically flows from high to low areas. If the terrain's complex with uneven slopes, energy gets blocked. That's when quantum tunneling appears. A particle can tunnel directly from high-energy zones to low-energy ones, ignoring terrain barriers. Once in the low-energy zone, it expands like a seed, forming a new bubble universe. Remember, in string theory, space has multiple dimensions. These bubbles grow in extra dimensions invisible to us. So, within those giant cheese holes, new bubble universes emerge inside existing ones. Bubbles within bubbles, like Russian nesting dolls. This massively layered cosmos is called the landscape parallel universe. The seventh parallel universe will leave you utterly speechless. The author calls this the weirdest version of all parallel universes, the holographic parallel universe. To understand this cosmic model, let's begin with a short story. Once, a tyrannical emperor had a truth-telling scientist in his realm. Wanting him gone, the emperor's sycophants devised a cruel plan: throw the scientist's entire family into a black hole. Hearing this, the family wept bitterly, except the scientist, who smiled. On execution day, the family boarded a spaceship heading toward the black hole. The emperor and his ministers observed through telescopes as the ship approached. By analyzing photons, the telescopes showed the ship burning violently in intense radiation at the event horizon, vanishing completely. The emperor and ministers laughed heartily, satisfied. But unknown to them, the scientist's family comfortably passed the black hole's boundary at that very moment. Though the scientists knew they'd eventually reach the singularity and be torn apart, this supermassive black hole would take millions of years, enough for the family to live full lives. From the emperor's view, the scientist died, but from the scientist's perspective, he lived. So which reality is true? The answer is that both are real. You might say, that's ridiculous. How can one spaceship have two coexisting outcomes? First, understand this isn't a physical paradox because observers inside and outside the black hole can never meet. The emperor can't jump in to tell the scientist he's dead, nor can the scientist climb out to prove he's alive. So however incredible it seems, both perspectives hold true. The only difference is the frame of reference. Using complex math, scientists prove string theory inside special spacetime equals quantum field theory on its boundary. Confused? Simply put, Chinese equals China, people equals people. Different languages describing the same reality. Physics works similarly. Scientists developed a translation formula. Input physical processes on the black hole's boundary, and the formula outputs equivalent processes inside. You know holograms, film with meaningless lines, arcs, and swirls. But under laser light, it transforms into vivid 3D imagery. The black hole's boundary is the holographic film. Its interior is the projection, merely a manifestation. Scale this to the entire cosmos, and you get the seventh parallel universe, the holographic multiverse. Here's the holographic cosmos. A giant spherical boundary encodes all universal information. The universe we see, galaxies, mountains, oceans, cities, humanity, is actually a hologram. We inhabit this hologram. Everything around us is just the cosmic edge. A 2D plane's projection. All matter is illusion. Information stored at the cosmic edge projected inward. But can the edge really hold all cosmic data? Scientists proved information within any space must be less than its surface area.
How astonishing is surface information storage!
Consider a 50-centimeter radius sphere. Its surface can store up to 10 to the 70th bits of information. That's about a billion times an EB. There are 7 billions in total. So a holographic universe is theoretically entirely possible. If the holographic parallel universe truly exists, the physical processes at the cosmic boundary would be like a puppeteer pulling strings, manipulating everything about us. We're merely his projections. Our world and the world at the cosmic edge form the most perfectly matched pair of parallel worlds. Just like you and your shadow moving in lockstep. That's all for now. We've covered 7 parallel universe models, all derived from physical theories. Now let's shift our thinking. What if we put aside physics and take the steering wheel into our own hands? Now let's look at the final group of parallel universes, which go beyond physics and involve some philosophical speculation. American cosmologist Andre Linde once said, "The temptation to play God is irresistible." The scientific community has pondered an enticing question: can humanity master the universe's evolution and create a parallel universe according to our will? Theoretically, yes. As mentioned earlier in inflationary parallel universes, with an inflation field, space expands to form a bubble universe. All we need to do is create a seed of the inflation field, and it can trigger the initial expansion. According to calculations,
This tiny seed of inflation space only needs a diameter of 10 to the minus 26 centimeters. Its energy converted to mass is lighter than a moment. You could practically carry it in your wallet.
Such a minuscule seed would expand rapidly in an instant, becoming vaster than the observable universe. Once the newborn space expands to a critical size, it severs the umbilical cord to the parent space, and an independent inflationary universe is born. Creating a universe sounds easy, but there are two issues. First, the inflation field is still just a theoretical concept. We don't know if it actually exists. Second, would creating a new universe consume our current world? No need to worry, the inflation seed doesn't encroach on our space, but creates new space in other dimensions. We can't see it at all, which is both comforting and frustrating. After painstakingly creating a universe, we can't see it, touch it, or even be sure it's been created. So why bother? If we can't see a real universe we create, what about a virtual one? Perhaps humanity can create the eighth parallel universe, the virtual multiverse. If you've seen The Matrix, this virtual parallel universe concept won't be unfamiliar. In the film, human bodies float in nutrient-filled pods, plugged with connectors receiving sensory signals. Humans live entirely within virtual computer simulations, technically challenging but feasible. A 100-year lifespan involves approximately 10 to the 24 brain operations. Multiply by Earth's total population, approximately 100 billion humans, equals approximately 10 to the 35 operations. That's 10 to the 35th operations total. How enormous is this number? Consider, the sun's mass is approximately 10 to the 35th grams. A computer the size of Earth could simulate all human lives in under 2 minutes. And that's with current tech. With quantum computing, a laptop-sized machine could finish it in a fraction of a second. All computations ever performed by humanity. Thus, we'd create a vivid virtual world. Virtual residents would perceive their world as real as we do ours, raising an agonizing philosophical question. Are we currently living in a simulation? We can't prove whether our world is real or virtual. Like Zhuangzi's butterfly dream. He couldn't tell if he was a man dreaming of being a butterfly or a butterfly dreaming of being a man. Similarly, you can't know if you're just a brain floating in nutrient fluid, manipulated by higher beings. Using computer programs to generate your consciousness and experiences, if this is all illusion, humanity remains trapped in doubt about our reality.
Thus, we've explained 8 types of parallel universes.
You might wonder, why must these universes be so bizarre and diverse? Why is this one about inflation? That one's string theory, this one's quantum mechanics, and that's about holographic projection. Philosophy has a view: if you don't want to explain why a theory is unique, don't consider it unique.
So our final parallel universe model encompasses all possibilities. No single model is special.
This vast collection is called the ultimate multiverse. Its key difference from the previous 8 is lacking independent principles, yet it solves a major scientific philosophical dilemma. That is, why does our universe follow specific mathematical laws instead of others? First, we must understand that mathematics underlies physical phenomena. From general relativity to quantum mechanics, physicists find equations seemingly tailored to specific domains. For example, Dirac discovered an extra solution in quantum equations from which humanity found the first antimatter. So why this coincidence? Why do we have precisely these mathematical laws describing our universe? The answer's simple. All possible mathematical laws exist. Countless universes have countless laws. We just happen to inhabit one governed by laws allowing human existence. This is the ultimate multiverse's purpose. Here, every mathematical theory describes a real universe, raising an even deeper question. For centuries, mathematicians and philosophers debated: did we invent math to describe the cosmos, or discover pre-existing formulas? We may never answer this definitively. Okay, that concludes the hidden reality. After these thought experiments, you might ask, which parallel universe actually exists? Truthfully, even the author isn't certain. He aims to show how theoretical reasoning guides physicists. To envision our universe as one possibility among infinite cosmic variations, I hope readers close this book with a richer, more vivid understanding of possibilities. In this austere, dark universe, we stand on a tiny earth, yet, with our limited vision, have achieved profound understanding. Precisely this understanding reflects the universe's grandeur, and precisely this understanding proves we've touched the hidden reality of this cosmos. That concludes our interpretation of this book. Reading notes are below the audio. See you next time.